Okay, so here's a sigma notation problem. We want to use these formulas to rewrite this expression, the sigma notation expression, in terms of n. So we're given that k squared is equal to n and n plus 1 and 2n plus 1 all over 6. And k is equal to this right here. So I'm going to multiply 2 times this expression here and 5 times this expression here. So I get 2n, n plus 1, 2n plus 1 all over 6 plus 5n, n plus 1 all over 2. I could cancel this 2 and the 6 here, but I'm going to need a common denominator, and the common denominator looks like it's going to be 6 regardless if I cancel those 2 or not. So I'm going to leave that 2 there. So I'm going to multiply this one by 3 over 3. While I'm here, I'm going to multiply these two right here. So I get 2n, n times n is n, n times 2n is 2n squared, plus 2n plus 1n is 3n, plus 1 plus 15n, I'm just multiplying the 3 and the 5, n plus 1, and since I have a common denominator, I'll write over a common fraction, which is 6. Multiply those two, I get 4n cubed plus 6n squared plus 2n plus 15n squared plus 15n all over 6. Collecting like terms, I get 4n cubed plus 21n squared plus 17n all over 6. Factoring out an n, I get 4n squared plus 21n plus 17 all over 6. Now, this is factorable. 17 is prime. And I want to add the factors of 4 and 17 to give me 21. Well, 4 plus 17 is actually 21. So we have all the information we need. So I'm just going to put an n up front. And since 4 plus 17 is 21, I'm just going to leave 4 as 4, not 2 times 2. So this is 1n, because 4n times n is 4n squared. I don't want to multiply the 4 and the 17, so I either can put the 17 here or put the 17 back here. If I put the 17 in the back, it'll multiply 4 times 17. Well, that's not going to give me 21. So I don't want to multiply those two. I'm going to put 17 and 1 there, respectively. And that works, because this is 17n, that's 4n, that's 21. 4n squared, 17, got it. So here's another sigma notation problem. The sum on k cubed is this one over here, and the sum on k is n and n plus 1. Just put a 2 in front of it. So I get n squared times n plus 1 squared all over 4 minus 2 times this here, which is n and n plus 1 all over 2. I can cancel those two 2's. And I'm going to multiply this n plus 1 quantity squared, so that's n squared plus 2n plus 1 all over 4 minus n times n plus 1. Counterproductive here because I need a common denominator of 4, so I'm going to multiply this one by 4 over 4. I'm going to multiply this n squared through, so I get n to the 4th plus 2n cubed plus n squared minus, I'm just going to put this 4n up front, I'll deal with that in a second, all over 4. So this is done. I just need to multiply that negative 4n, so I get n to the 4th plus 2n cubed plus n squared minus 4n squared minus 4n all over 4. Collecting like terms, I get n to the 4th. It's a sad looking 4. Let's just erase that, make it look better. There's no other 2n cubes. This 4 looks the same. Minus 3n squared minus 4n all over 4. I'm just going to factor out an n cubed plus 2 2n squared minus 3n minus 4 all over 4. Not factorable, so we're going to leave it like that.